7, 6, 4, 3, 2, 1, and liftoff.
Hi. Oh, who am I? I'm Jensel the Corner. I do science, atheism, and LGBTQ stuff over on my channel. Plus with this stuff. We should not be muted. Okay, why are we muted? It shouldn't be muted. No, that definitely should be capturing audio, and they can't hear us. Yeah, no, they can't hear us. No, it's not you, it's... Oh, they can hear me, they can't hear you. Alright, so that's me, so, let's just try that. Talk, Mary, see if they can hear you.
Okay, can people hear me now? So, we'll just got to wait. Okay, apparently I'm the only one muted, so... Oh, the doc is muted as well.
Okay, and they can't hear you. Joyous.
Sorry, Dr. Karl, this tends to happen all the time. So this is a program called OBS.
They can hear you now, okay.
Okay, Dr. Karl, could you please say something for us?
It wasn't OBS that was the problem. It was it was the audio mixer being stupid. I've just got channels, and that's okay. Awesome. Go again, Mary.
Okay. Hi everyone. Sorry about that. So apparently now you can now hear us. Because sound problems always a thing.
They're always a thing.
Okay, for those of you who do not know me, my name is Meredith. I run a channel called Nevadia. Please like, share, subscribe, all the jazz. But don't talk about me. Let's talk about my wonderful co-hosts. They're both wonderful. Everyone, please, Jen, who are you?
I'm Jen from Jensel the Corner. I talk science, LGBTQ, and atheist stuff over on my channel. I debunk stupid a lot because I hate people who deny science. It really frustrates me. So, yeah.
And the absolutely amazing, wonderful, coolest person with the most awesome shirts on the planet, Dr. Karl Krishnan. Because I've never been able to...
The correct Australian pronunciation of my surname is Wheelbarrow.
Wheelbarrow. Okay. Karl Wheelbarrow, how are you?
Very well, thank you. Good morning and lovely to be here.
So, Dr. Karl, everybody who is Australian and is alive as an Australian, who over the age of 4, knows who you are. But we have a lot of international people. So can you please explain who you are?
I've had a lot of education, 28 years of education for free, including 16 years at university with degrees in physics and mathematics and biomedical engineering, medicine and surgery, worked in all those fields, as well as several non-degree years of study in computer science, astrophysics, philosophy and electrical engineering. We've been working in science communication for about a third of a century. I've written 46 books. I was a doctor in a kids' hospital. I was a roadie for Bo Diddley and Chuck Berry once, and was a TV weatherman and a taxi driver and a labourer and a hospital scientific officer and a T-shirt maker and an engineer and a physicist. And what I do basically now is tell stories and answer questions on radio. So I've got about half a dozen radio stations around the world where I answer questions where people ring in completely cold questions, and I try to answer them, which I can do reasonably well because of my high degree of education. I'm not particularly smart, but I am highly educated and therefore relatively knowledgeable, but not very smart.
Oh, I think you're a smart cookie. Yeah, I totally agree, but well, no, I disagree with you saying that you're not smart.
Oh no, my IQ is only about 110. So I've come across people who are smarter than me all over the place, in medicine, in physics, in engineering. And so, for example, in medicine, we were thrown into studying the kidney, and this colleague I was studying with, she was able to sort of leap from mountaintop of knowledge to mountaintop of knowledge and go, oh yeah, I understand all of that. And I said, but what about this, sort of scurrying through the valley? And she said, oh yeah, that's that. And I had to go through it slowly, whereas she could just go through it quickly and understand it deeply. Whereas in some cases I said, but why is that? And she said, oh, because of this. Oh yeah, okay. And that was one occasion on which I knew that there were people smarter than me. The same thing happens in physics and also in engineering, where you come across people whose insight is such that they can work with the data that you both have, but they come up with a much better answer.
It's frustrating, that, isn't it?
No, it's part of the learning.
It's not.
Because you find your own strengths and you go for what your strengths are, if you have any. And if you don't, well, you can develop some, like Arnold Schwarzenegger. So did he get to where he is by lying on the lounge, watching TV and drinking beer? Or did he go out and pump iron in a different way? Whereas other people do 3 sets of 10, he'd do 10 sets of 10. Read his autobiography. Fascinating.
I mean, it is very much the case that the different perspectives, because of the different ways you have to work through things, actually lets you focus on different areas. So the fact that you'd had to work harder to get where you were actually meant that you'd actually pick up some things which other people who can just jump from one point to the next would actually miss.
Sure, and that makes me better as a science explainer and author, because I've gone and done all the hard work that the average person has to do, whereas a smart person would just go, oh yeah, that's obvious. Whereas to me, I want to understand it's not obvious. I have to learn it.
When I was doing martial arts, I was told the people who started off struggling as a white belt, when they got to a black belt, they ended up being a much better martial artist because they actually had to dig further and deeper into the techniques. So I think that works both intellectually and physically as well. So.
Sure. Yeah. Except the trouble is that if you do self-education, which I've done some of along the way, there are gaps in your knowledge and you don't know the gaps are there, which is why it's good to have a course where people who are really knowledgeable have already done all the hard work for you, and you just sort of follow along and do whatever they tell you to do.
Yeah.
So, okay, so we are here to talk about your next book. So, yes, could you tell us a little bit about that? Because you've also asked a few.
Okay, I'm going to blow your mind on this one. You've heard about black holes and stuff?
Yeah.
I think so.
Yeah.
I genuinely
heard about black holes.
I've definitely heard about black holes.
And they come in different masses, we discovered the nearest one to us was only about 5 times the mass of our sun. That's only about 1,000 light years away.
Yes,
and then the one at the center of our galaxy is about 4 million times the mass of our sun. And we discovered one that was about 8 billion times the mass of our sun. Okay, now here's a weird thing, right? They all have the same size, which is 0.
Wow.
Black holes do not have a size. It is not one of their properties. In the same way, it is not one of my properties that I am the Terminator, nor am I the world heavyweight cage fighting champion. That's not one of my properties. In the same
Wow.
way, black holes have got 3 properties,
Mm.
and size is not one of them.
Wow.
Their
So
3 properties are that they can have mass, they can have angular momentum or spin, and they can have charge. And that's it on the outside. On the inside, we have no idea. But on the outside, that's all that we can ever know about them from the outside until we work out how to get inside them. So black holes have no size. Isn't that amazing?
That is weird, considering that
when we
you
think
know,
of a black hole, we tend to think of the black hole as being the event horizon. But that's not true. The black hole is smaller than the event horizon. That's just the point at which nothing can escape, because you'd have to go faster
Yeah.
than the speed of light to escape. So, yeah.
Well,
So can you explain the event horizon for those who are not fully up on it there, Dr. Jen?
Okay.
well, a black hole is significantly smaller than its event horizon.
Well, it's infinitely smaller. There is no size. The size is not small. It's 0.
Well, mathematically, it's 0.
Well, physically, it's 0.
0. Well, we can't actually know that until we could actually get beyond the event horizon and see the black hole. I mean, from an observational point of view, a super dense neutron star that has an event horizon would be, from our perspective externally, no different to a black hole which has a singularity.
You are 100% correct.
So technically a black hole could be massive within its own event horizon, but we have no way of knowing.
Well, it is massive. We can measure the mass by how long it takes stars to go around it, but the size, we're working purely off theory, and the nearest one that we've found to us is only 1,000 light years away. But there's another problem. You see, we've discovered about 100, a couple of dozen black holes in our galaxy.
Yeah,
we're short by about 999,999,900. In other words, there should be 100 million. And we've only discovered 100.
But
where are they? We don't know.
To quote Red Dwarf, space is black, black holes are black. They're actually kind of hard to see.
Exactly. But on a more, relevant role to most of us, if you're born, you live, you die, you eat, you poo. We've discovered an animal that has a transient anus.
Okay, now that's fascinating.
Look
at your face, Vero.
Dr. Karl, can I rewind a little bit, because you were talking about something. I have asked several people this. You're in good company. This question has been asked to Neil deGrasse Tyson. So if you had an indestructible ship with the smartest people in the galaxy, and you had a choice to study a black hole or a neutron star, but you can't enter the black hole, which one would you choose? Neutron star or black hole? And which one?
Well, probably the neutron star, because there's more interest on that we can look at and perceive. And I'm working up a story on the neutron star, and apparently it's got a whole bunch of different layers as you head down towards the center. Whereas with a black hole, from the outside, they're simple, according to our mathematics, which is different from what they really are, because our mathematics could be wrong. And they have only the 3 properties of mass, spin, and charge. Whereas a neutron star's got a whole lot of other stuff going on. On the other hand, there's always ER and EPR. And you know what I'm talking about here. ER is Einstein-Rosen, and EPR is Einstein-Poldovsky-Rosen. And they got together, a group of 2 or 3 of them, in 1935 or so, and wrote these famous papers called ER and EPR. And in one of them, I think it was ER, they come up with the concept that you can have something that is infinitely dense. It has 0 size. So any mass that it's got, you divide it by 0, means it's infinitely dense. They don't call it a black hole. That name didn't come until the 60s. But they talk about this thing that is effectively a black hole. And then in EPR, they do some mathematics and a lot of hand-waving stuff, and come up with a conclusion that it's not singular. Now, that's a fancy word. So what does not singular mean? Okay, here's my fingers. They're not singular because they're joined onto my hand, which is joined onto my wrist, which is joined. Yeah, okay, everything's joined together. But my little Fisher space pen, which can write uphill and has 40 psi of carbon dioxide in it of nitrogen to drive it, this is singular. If I drop it, it vanishes. It goes somewhere else. It's not joined to me. And what EPR says is that black holes are not singular. Wow.
Yeah. So
Black holes
about,
are somehow
Rose-Einstein
joined.
bridges, so you're basically wormholes.
Yes, they don't actually say wormholes.
No,
but
because that's a later term
what
like
we're
black hole
thinking.
is.
Well, we've got no proof because we've only done mathematics. And by the way, the good news is that with the missing 100 million up to a billion black holes, there should be one with only 30 light years of us, and there could even be one in our solar system playing the part of the mysterious Planet 9, which should really be called Planet 10 out of respect to Pluto, but that's another story.
Yeah.
Sorry for the interruption. So, did you want to talk about wandering anuses? Well, that's
No,
that's
not wandering. Transient.
Transient.
So
Transient.
moving not in place, but in time.
Oh, okay.
So for most of us, you pretty well get born with one. You got it there 24/7 until you die. Not this creature. It's a ctenophore, which is I had to look it up. Got no idea. I think I could be wrong with the pronunciation. Ctenophore, and it's about 5 centimeters long, and it's a little worm that swims around the oceans. And scientists are interested in it because it goes back virtually unchanged to 514 million years ago. You know, and you're thinking, okay, Cambrian explosion, diversity of life, all that sort of stuff. Anyway,
but that's almost pre-Cambrian, isn't it? So
yeah, it's in that sort of. Well, they talk about the boring billion, but we can get onto that in a minute if you like. But anyway, getting back to the worm with the anus. When it's a larvae, it will grow an anus every 10 minutes. But when it's a fully grown 5 centimeter long thing, it'll grow an anus every hour. So it needs to have a poop. It then grows an anus, has a poo, then the anus vanishes. And what happens is that part of its gut at the far end begins to expand and expand and expand and turn into a little ball, and then pushes up against the inside of the skin of this ctenophore near its rear end somewhere, and then suddenly the bubble merges with the skin and the contents push out. And then it's had a little poo, and then closes up again, and the anus vanishes.
it's almost like a pimple poop, isn't it?
Yeah, but
except it
bigger
doesn't
in
actually
volume.
break the skin. So
Well, it doesn't, the skin opens, but I don't think you'd count it as a break.
Yeah.
More of a just
a parting
fusing, parting of the waters or something.
Parting of the waters, yeah.
Yeah, and we also discovered a scorpion that can do something that's even worse than in your life. For example, losing your phone would be pretty devastating, right? This guy loses his anus.
Wow.
He's got one, but he loses it.
Like, oh, that's
so
just
for
that's
part
weird.
of his life, he cannot poop.
Well, what happens is that they're a little scorpion about so big. They're rare in South America, and they've got a body and front legs and back legs and a tail and a sting at the end of the tail. And the anus is not between the rear legs. It's in the tail up near the sting. And if it is attacked by a bigger creature, it will do what some lizards do and dump its rear end, leaving it behind as a tasty morsel for the outraged predator or the hunting predator to go and feast on. Because you can see this happening where the lizard's being chased and then suddenly it drops its tail and there's this big fat tail full of fat and is wriggling away because it's got its own muscle and nerve supply for a little while. Yeah. And so the predator is going, either I can eat that smaller bit and be guaranteed of getting a good fatty meal now, or I can go chasing the lizard and I might get him and I might not. And normally they just go for the bit of the tail that's left behind it. There are cleavage points and they break off and it lives nicely. So in the case of the scorpion, sometimes it chops off its tail voluntarily and loses a bit that has the anus in it,
So it can't
and then
fit.
it can't poo. And so sometimes it'll just keep on building up feces inside its body until the pressure is so great that another segment of the tail will pop off, but usually it doesn't. And during that 8-month period that they're still alive for, they can even father babies. I don't know how scorpions have
Wow.
sex. Probably carefully.
Wow.
This is really old information that I'm remembering, so the details might be a bit dodgy, but between scorpions with scorpions, what's more closely related, the spider or the tick? Do you think?
Whoa. I'm really bad on my invertebrate biology, evolutionary biology, so I'll just take a guess. The spider has 8 legs, and the tick has I don't know how many. So I'll go with what I don't know and say the tick. How's that for a wild guess?
I think you're correct. Again, this is old information, so you're going to have to look this
What?
up yourself.
Not peer reviewed, not checked.
Ask a question
Oh
you
my
don't know the
goodness.
answer to.
Because the scorpion had a whole genome duplication millions of years ago. So it just evolved really, really quickly because the genome of the scorpion just doubled, and it had all of this all of the genetic information. So it was able to evolve really, really quickly from one point of the the genetic divergence from spiders in the arachnids.
Wow.
So
So
yeah,
is that not diploid, but quadruploid or whatever they call it?
The whole genome got probably quadruploid. I think think you're right, but the whole genome just on one little baby spider got the genomes just duplicated, and then all of a sudden evolution had so much extra information to play with, and that's why that's where the divergence came from.
Wow.
Yeah.
I'm
So
always
again,
amazed
this is
by how a bunch of inanimate chemicals can start breeding.
yeah, it
Where
is
does life
incredible.
come
isn't
from?
it?
That's a big
It's
one.
insane. Yeah.
Abiogenesis is probably one of the bigger questions that we have in science to answer as far as earth sciences go.
So A means not. Bio is life. Genesis, where it comes from. So how do you get life from non-life? Is what? Yeah. Still haven't solved that one. It's solved it in the sense
We've got
we've
lots
got a
of good
bunch of
clues
theories.
to it, but we don't know. But that's
We haven't
the
been able
thing
to do
about
it in
science.
the
Being
laboratory.
able to say you don't know is one of the best things of science.
Yeah, I love that bit.
I'm just going to quickly do a little bit of housekeeping. I'm not monetized yet, so I can't receive super chat. So if you've got a question you want to ask Dr. Karl, just send me. It doesn't even have to be much, like a cent or something like that, to my to my PayPal account, which is being linked in the description by Critical Cripple, and just put your name and your question, and I'll be able to ask Dr. Karl for you. So yeah.
That's my job, answering questions. I love it.
You do have such a
And
great
we
job
are
of
very grateful for you. Yeah, you are amazing.
I mean,
You
as
are.
I was
you
showing
too,
you
Karl.
earlier, my green screen hates it. That's the second book that I got when I was at TAFE at this point, but I still loved your books. And that was absolutely fabulous moments in science, and this was amazing for me. Actually, to read through it and see, and to get that feel for science that you gave so many of us, back in the 80s and early 90s, the common feel for science is what drove me to want to get into maths, and that. So.
Oh yeah, what's your favourite equation?
I love all the maths. I love calculus.
Calculus is cool. I love calculus. It's just so weird.
Awesomely
So you don't
fun.
have a favourite equation or identity?
Do I actually have a favourite equation?
Or identity? I mean, surely you've got a favourite organ, a favourite amino acid, a favourite colour,
Why do
favourite
people
friend.
always want that? You've got to have a favourite something, because I mean, I like all equations for the way we came up with them. I mean, if you actually sit down and you you actually go through the thing of deriving Newton's equations, like even force equals mass times acceleration, it is a fascinating thing to actually go through the same processes that he had to go through to get to that point. And I think that's the beauty of math and of science itself, is that even though these things are discovered, you can go back and rediscover them for yourself. In a sense, you can experience what they had to do to get there. And I find that
How do you derive F equals MA?
I can't remember, to be perfectly honest. It was a long time ago.
I remember I was teaching in New Guinea, and I was in physics, and we went through into Newton, and there's his second equation, force equals mass by acceleration. And it took me about 3 months to explain it to the students and explain it deeply. But at the end of that time, they all knew all of Newton's laws. And for the first time, I really understood F equals mass by acceleration. And this was a few years after we went to the moon, the Americans went to the moon. And I'm dealing with people who have never experienced an external acceleration.
Wow.
They've never stood in a lift. They've never been in an escalator. They've never been in a motor vehicle. They've never been in an aeroplane.
Yeah, so they've...
Wow.
Yeah, no, that makes it even more difficult, doesn't it? Because some of the concepts, especially if you're having to talk about inertia as well, because you've never experienced inertia at all either. Then, I mean, you have walking, but your experience as walking, you don't really notice that. You're not moving at speeds. Like if you explain,
you're implying the acceleration. The acceleration is not being done to you.
No.
Right? You can't just sit there and say, oh, wow, I'm being accelerated. I'm being pushed this way or that. So the way I got around it was that I had 30 students in the class. So I had a Land Rover. So I'd shove them in the back of the Land Rover and then do wheelies in the parking lot. And then one at a time, each student had a chance to pull on the handbrake. I was in two-wheel drive, rear-wheel drive, to pull on the handbrake, change the friction ratio on the back wheels, and suddenly the back end of the car would swing out with about 10 students in the back. And I did this, and every student got to go, and I wore a bit of rubber out, but for the first time, some of them had actually experienced acceleration and friction.
Yeah.
Oh, wow.
And inertia.
And inertia, yeah. We still don't understand why inertial mass is equal to gravitational mass. It doesn't make sense. Well, it does, but we just don't know.
Well,
that's a big problem.
The theoretical thing is because of frame equivalence, but it doesn't make any intuitive sense.
But it's real, though.
It is real, yeah. No, it is. There is no difference between an accelerating frame and a gravitational frame. That's a mind-blowing concept to realize that
it is hard. Story here, which will be more. Where are you, mouse? Okay, come over here. Those two stupid screens. There we are. Okay. We've been making coffee the wrong way for the last 6 centuries.
Oh, okay.
I have noticed a couple of questions while you're doing that. Dr. Karl, is there an equivalent to a white hole?
No proof. All we have seen is that there are spots in space where there's apparently nothing, insert black hole, and we've seen stuff orbiting around it at such a speed that the thing that is orbiting has to have a mass of 4 million times the mass of the sun. And that's the one in the middle of our galaxy.
Yeah, that's the only reason we know Sagittarius A star is there, is because we've seen the orbits.
That's right. And that's right. And the amazing thing is that they're orbiting something like 15 years, and they're way out at 10 times the distance of Pluto, and Pluto takes 250,000 years to go around. So normally, orbiting just a little old star, they'd take tens of thousands of years, and they're doing it in 15, and they're coming in really close. Now, the second thing is we have never seen stuff falling into the black hole, but all we can do is see it as it's heading for the event horizon. In fact, we can't even see the event horizon. We can just see the stuff outside the event horizon jostling up against each other. So you've got one star here, which is, say, a big red giant, and over here there's insert black hole. And stuff is being sucked off the big star, and it goes into a spiral around the supposed black hole. And as it does, it runs into each other and gives off various types of radiation, including X-rays. So we've got proof of that.
We've actually
It's
got a photo
something
of it
coming.
now.
Yeah, which was amazing.
It was.
That first photo of the event horizon, or of the bent light around a event horizon,
Yeah.
it took 2 years to process from about 8 radio telescopes around the world, and they had to bring together the data. There was so much data on 1/2 ton of hard drives.
Yeah, no,
Whoa.
they couldn't do it. There was so much data, it couldn't be done over the internet. They were flying these hard drives around the world to get them to the supercomputers to reprocess.
Oh my goodness.
Yeah.
That's
And these are not hard
insane.
drives in cases. These are just naked hard drives, because the weight would have been a ton instead of 1/2 ton. And then they spent 2 years processing the image by 4 separate teams using different algorithms, and they all came up with very close to the same answer as each other and to what they had predicted with mathematics. And so they said, okay, we're pretty confident that this is right. That first photograph did not give us any new information.
None
It just showed, no, but it did show that we now had the technology, albeit fairly slow and complicated and clunky, to take a photograph of the stuff around a black hole falling in. We'll get faster and we'll be able to learn new information. But the first one, you have to do the first one before you do the second one. Getting back to our question, we have never seen stuff coming out of nowhere, which could be the other end, the black hole. We have seen quasars, we've seen cosmic jets, and these cosmic jets can be thousands of light years long, not just a few light years long, but thousands of light years long, and traveling at up to 60% of the speed of light. That's matter.
Jeez.
Stuff.
That's incredible.
Yeah, and 5,000 light years long. Now, we're pretty confident that is not stuff coming out of a white hole. We're pretty sure that is just the stuff falling into the event horizon, spiraling around, add various mathematics, one going out north, one going out south. It all makes sense. But so to answer the question, we have magnetic fields. Yeah. And so we have zero proof that there is actually a white hole or a white or a wormhole. It might be there, but we got all sorts of arm-waving mathematics, but zero proof. Next question.
What is your favorite element?
Oh, plutonium, of course.
Plutonium? Why?
Oh, yeah. You see, you've got 6 possible structures for crystals.
This is where I'm like, haha, I understand this one. I'm doing a chemistry major.
Field, isn't it?
This is my field.
Plutonium is the only element that has all 6.
Yeah.
So you can let's just pick a cube, and so on the top face of the cube, 1, 2, 3, 4 atoms, and down the bottom, 1, 2, 3, 4. So you got yourself a cube with 8 atoms, on the perimeter, on the points of the cube. Okay, that's number 1. Number 2, shove another atom in the middle. So that's a body-centered cube. Then shove another atom in the middle of each face. That's the face-centered cube, and so you go, and so you go. And only plutonium has all 6. So, Dr. Meredith, seeing how you're doing chemistry, what's your favourite element? So we kind of missed out with Jen not wanting to have a favourite equation yet. It'll probably bubble up in a minute.
You're gonna annoy me, aren't you, about that?
Yeah. Well, I came prepared. It's bismuth.
Oh yeah, you said that.
Unfortunately, it sort of seems to have. It used to be much brighter, but I think with the sun, the beautiful rainbow sheen is just, it's sort of dying. But bismuth is my favorite.
Where is it in the periodic table, and in what group, or is it?
I can't remember off the top of my head. It's next to lead, I think.
Oh, so it's relatively dense. It's up in the
This is pretty weighty. It's pretty cool. It's in the poisonous what's it called, the poisonous hallway or something like that. So that you've got lead, thallium, mercury, and then just all of a sudden you've got bismuth, which is so inert.
Really?
It's very inert. It's we actually use it to help people who have H. pylori infections. It's also very slightly radioactive, to the point where a lot of people argue it's not, because its half-life is like longer than that of the universe's age when it goes into heat death or something like that.
Yeah.
So it's really quite amazing. This is one of my favorite things about it.
Yeah.
It's for people who aren't scientifically minded, this is like, what the hell, why is this crazy? But its solid is less dense than its liquid.
Hang on. Like ice.
It's like
When
ice.
it changes state as the temperature drops down, instead of shrinking, it expands.
Yeah. So
had no idea.
if I was to have liquid bismuth, this would float. So for people who don't understand why this is important, when something becomes cooler, it tends to contract and sink to the bottom, and that's like for most things. But as with bismuth and with water, it floats to the top, and that property of the fact that water floats is the reason why the Earth is not a solid frozen ball of ice. Because if water sunk, then there wouldn't be enough heat to be able to melt the ice, and that's one of the properties as to why life is really important around water, because of the fact that water floats when solid. So that's
about 6 million years ago, we had snowball Earth as part of the ice ages, and so the Earth was virtually ice from pole to pole, with a few little gaps here and there. But the Pacific Ocean was pretty well covered with ice, with a few volcanoes poking through, which eventually chucked out so much carbon dioxide they were able to reverse it. And the trouble is, if you have the ice at the top and the water at the bottom, well, then the ice is white and it reflects the heat. And so the thickness of the ice just increases down, and then finally it stops after a while. You've got enough insulation, so you've still got liquid water at the bottom and you're safe. So under normal circumstances, you're safe. But if it was the other way around, if the ice sank and it was at the bottom, then at the top you got black stuff which absorbs the heat. Hang on. But there's not enough heat coming from the sun to reverse that. The important thing is that you're in an ice age for whatever reason, and the ice spreads and spreads and spreads to the surface until finally you're left with a few fish flapping around. Ignore the stuff about the white versus black. That was a detour. It was wrong. The point is, okay, I can explain that later, but the point is that the ice, because it floats, acts as an insulator, and the water is underneath, and fish will survive down there at a temperature of minus 1.8 degrees C, because they've got a bit of antifreeze in their blood to stop them from freezing up.
Yeah. So that's pretty crazy.
Is your favorite element because of that. What do you use bismuth for?
Oh, it's one of them.
You use it for anti-pylori treatment?
It's in Pepto-Bismol. It's like the gas, like, when you have acid reflux, they use it in that. It's an H. pylori treatment. There's I think there's a couple of things that they use it for electronics. Because this is just stunning. As I said, this is probably the better, because it makes this beautiful rainbow colors. A lot of people use it as a crystal to look at, because it's pretty. It is absolutely stunning. When grown in a lab, this is actually lab grown. This is its natural formation when grown in a lab.
Pure bismuth, or does it have a few other atoms of other stuff in between?
It should be roughly 100% pure.
Wow.
Yeah. So that color, that's how it oxidizes. That's the shape it makes. So it's pretty, and the fact to me that it's stuck in the middle of the poisoner's hallway, because you've got thallium, which is quite deadly, and it's tasteless, odorless. It's the poisoner's poison, and it's very, very, it does awful things to you. Then of course you've got mercury and lead, and everybody knows that those are quite toxic to the body as well. I can't remember the mechanism as to why thallium kills you, but I think it replaces maybe the phosphorus in your DNA, or it does something to your DNA. That's why when you have thallium poisoning, like your hair starts to fall out and stuff.
Really? So it takes the role of phosphorus.
I think it does. Again, this is years old information. So please, everybody, I have ADHD, so my long-term memory can be a bit dodgy. So please take everything I say, double check, advocate for your own understanding, as Shannon would say.
Because with the ATP, which has 3 phosphates hanging off it, that's the energy currency of the body, which I only discovered when I studied physiology. And at any given time, you've got about 1 kilo of it in your body, and over a period of a day, you will break down and manufacture your own body weight in ATP.
Wow. I also have that as well. My boyfriend bought me that for Christmas, I think he did. So this is 99.99% pure bismuth.
Ah, when it's been heated up and then allowed to set by cooling down rather than grown in a crystal solution. Wow.
No, you can. If I melted this in my if I melted this in my oven, I think it's got a fairly low melting. If I let it grow, that's how it will grow. Like, it's not even in the crystal solution. It grows like that. That's part of its property of the atom.
Oh, well, two of us have favourite things. Somebody's out there hanging out being impartial and mature and not having.
You want to know what my favorite element is? Probably gallium.
Yes,
I love the whole idea of a metal that it can be solid at room temperature but just melts in your hand like ice cream. There's just something fascinating about that.
Is that gallium?
Gallium? It is gallium. Yeah.
It's gallium.
It's gallium. Okay.
And because it's non-toxic, as a practical joke, the chemistry student. Yeah, because it's as a practical joke, chemistry students would get a whole heap of gallium and make a spoon out of it. Yes, and then they would
the sugar. It'll melt in the tea.
And and so they'd be stirring the tea, and they'd bring out, and there's no spoon. So that's.
It tastes
I read a
salty,
book
apparently.
called. Oh, really?
So I actually haven't tasted it, but I just love it. I love the fact that you could make a dice out of it, hand it to somebody, and get them to hold it, and they go, "What happened to the dice?" There's milk.
Is that the book, The Disappearing Spoon?
Yes, that's where I found out about. Bismuth as well. That's a great book. I had so much fun with reading that. Yeah. So. Yeah. So
anyway, coming in.
Yeah. Is there any other questions?
Yeah.
Okay. I'm just having a look. So far, none in the chat. Come on. Don't forget, you can send me any questions in via PayPal. The links are in the being shilled. So if you've got any questions for me, or for Dr. Karl, or for Jen. Yeah. So, Dr. Karl, what's the name of your new book?
I think it's something about Dr. Karl's Surfing Through Science. The previous one, number 45, was Dr. Karl's Random Road Trip Through Science. So you can see that these are rather modestly named. Sorry about that.
That's okay. You sent us a couple of topics that you put in your new book. Hang on.
I've got the coffee one.
Yes. Tell us about coffee, because coffee is amazing.
Right. Well, firstly, the only real coffee is when water has been put through it under some sort of heat and pressure, and then the coffee goodness has been extracted. Like drip filter coffee, instant coffee, that's not coffee. That's just sort of brown water. Are we sort of good on that, or do you have different opinions about coffee?
I would agree with you on the drip coffee. I use a percolator. So like
a percolator?
The one where you put the water in the bottom and it just splurts out the top. That's what I use. Is that bad? I'm sorry.
According to, I'm going to get the name right, Istituto Nazionale Espresso Italiano, which is the National Espresso Institute of Italy, to make proper coffee, and that's espresso, none of this drippy stuff, is you start with about 6 or 7 grams of coffee powder ground, and then you shove hot water through it at a temperature of 86 to 90 degrees centigrade and at a pressure of some 9 atmospheres. For reference, the pressure in your car tires is about 2 atmospheres.
Yeah.
And then
That's a lot of pressure.
yeah, 9 atmospheres is a fair bit, but some people go up to 15. And you do this for about 20 or 30 seconds, and you should end up with about 27 mils of hot liquid. And the trouble is, that we've always had is the consistency problem. So you get these people who are highly trained baristas whose whole life is getting the best out of the coffee to give you a really good coffee experience. And we're talking espresso, not with lactose-free, glucose-free, fructose-free, with a hint of soy and some citrus, but just, the naked coffee essence. And they'll go to their professional competitions. And worldwide, all these people have gathered. And as one part of the competition, they each have to make 4 espressos and be judged on them. And they're all different. And we haven't been able to solve why until recently.
Oh, really?
They're all different. It turns out that if you grind the coffee, that you've got a 100-to-1 range of sizes. The coffee grind, and this is a proper grinder as opposed to a whipper-snipper bladey thing. You've got a range of sizes ranging from 10 microns, which is a bit bigger than a red blood cell, to 100 microns, which is a bit bigger than the thickness of a hair, to 1,000 microns, which is a millimeter, which you can see. You got a 100-to-1 range, but 90% of the particles are below 10 microns, and like 99% of the surface area comes from the small particles under 100 microns. And what happens when you shove the dream is that you've got this coffee basket, right? A basket, and then you shove the hot liquid in the top, and the dream is that under pressure, the hot liquid gently caresses each grain of coffee, extracts out the good bits of the 2,000 plus chemicals that exist in each grain, and then continues down the bottom to drip out through the little hole and into the cup with a little bit of crema on the top of it. That does not happen. It's what happens is that it randomly clumps. Because you've got such a range of particles from the small to the big, 100-to-1 range in size, sometimes you can have a whole bunch of little ones clogging around a big one, which then forms a solid lump. And so you think you've got yourself a nice big, bit of espresso basket with the water will go all the way through, but in fact maybe a bit this big over here just clumps into a solid lump. And no goodness comes out of that at all, and the water under pressure forces its way around it and through the coffee grains on the sides of the channels suck out so much goodness that they've got some of the bad chemicals, and they've completely ignored that bit here. And this is the consistency problem. It goes way back to the butterfly effect and chaos theory. And Edward Lorenz, you know about that? Should we explain that for the audience?
Why not?
Okay. So the butterfly effect is, in technical terms, great sensitivity to initial conditions.
Yeah.
So Lorenz discovered this when he was trying to forecast weather patterns. And at one stage, he accidentally made a little change of 0.01% in the air temperature. And suddenly got completely different results. Not just slightly different, completely different. And so you have a very small change at the beginning and it just snowballs on. And the classic example is the butterfly effect, where on the southern side of the equator, a butterfly in the Amazon flaps its wings for 2 seconds. And this changes the wind pattern so that 2 weeks later, on the other side of the equator, a hurricane, a typhoon, whatever you call them over there, instead of slamming into the American coastline, goes harmlessly out to sea. That tiny change made all the difference.
So
Okay.
that's actually true, or is that just impossible to tell?
What, the butterfly effect?
Yeah.
It's mathematically true, but to actually test it, you'd have to have 2 planets identical and then run through and all through. Right? So with regard to the coffee, the solution is as follows. Use less coffee.
And less chance to clump.
About 1/3 less. Secondly, grind it less finely. And this goes right against everything I was thinking, which is that you grind it more finely.
Yeah, that's what I would have thought.
So that you get more surface area. No, because you get more surface area, but it clumps.
So you end up with less surface
Area
area.
is
It's
unavailable to you.
counterintuitive.
Counterintuitive, a lovely phrase to drop into a conversation to prove you've got some sciencey background.
Yeah.
So less coffee, 1/3 less grind, more coarse, and for a shorter time. And then you end up with something that is consistent from time to time. So I've got a little atomic coffee maker at home. Look it up on Wikipedia, atomic coffee maker. And I can see the liquidy coming through, and it's just coming through in a thin little stream, and then it begins to sort of wobble around and make little bubbles. And at that stage, I'm moderately confident that I've gone into clumping. In fact, I can take out coffee at, say, 3 seconds and 5 seconds and 10 and 12 seconds, and each one tastes different. So I just keep on putting cups underneath to taste it. The disadvantage of using lesser quantities is that you end up making coffee for one. But you got a very nice coffee for one person, and then you have to repeat the process 4 times for everybody else at the dinner table.
I am one of those evil people who drinks decaffeinated coffee because caffeine gives me severe anxiety. I apologize. Yeah, no, caffeine gives me anxiety.
Can I ask, is that non-specific anxiety?
Yeah, non-specific. I just go, oh my God, I want to get out of here kind of thing.
Non-specific anxiety is dangerous and can lead to bad things. Specific anxiety is cool. I'm running late, therefore all I have to do is let them know that I'm running late or go faster or something. But non-specific anxiety, there's something wrong and you don't know what it is, and that can lead to disruption of your life, of your family. So anxiety is a real problem, and we've got some things that kind of work. And if you're lucky, we'll have something now, medical, pharmacopoeia that can help. So you've gone for non-caffeinated, but nevertheless, you are still getting the good effects. If you had read my 42nd book, you would have discovered the good effects of coffee, which are: it improves your life expectancy. It improves your outcome if you have heart disease or type 2 diabetes. Or,
I didn't know that one.
like I have, and sorry?
I didn't know about the diabetes one.
Yeah.
Coffee.
I should have read my 42nd book, And then,
Yeah, I'm guilty of not reading that one.
It improves mouth cancers and prostate cancer, which I have but you don't have, and which, in fact, virtually every male over the age of 30 has prostate cancer. But it won't kill them, they'll die of something. Yeah. Just, evolution isn't perfect. It's just good enough. If you're still alive when you've had your babies, evolution has done its job, Yeah.
And evolution was only thinking of humans living to about 30, 35 years anyway. So anyone who gets beyond there, you've actually outlived what we've evolutionarily got to get to. The rest of it is just us and our medical science. This has got us further.
But also our social sciences, that we take care of each other. If you read the book The Better Angels of Our Nature by Steven Pinker, you'll discover to your surprise that we are living in the most peaceful time ever in the history of the human race. Also, that's a hard book to read. It's got 1,024 pages, which of course, as you know, is 2 to the 10th, 1,032, I think it is, or 1,024. And then it's hard, but it's worth it. An easier book to read is Factfulness by Hans Rosling, that we are living in the most peaceful time ever in the history of the human race. But going back to recursive levels, back to you, Dr. Meredith, with the coffee. So people say that, hey, I want to get healthy, I'm going to give up coffee. I'm sure you've heard people say that. Exactly wrong. You should take coffee between 2 and 4 a day, depending. And even decaffeinated coffee has the health benefits. There's a whole bunch of chemicals like caffeic acid, CAFFEIC acid, and so forth. It's not just the caffeine. There's a whole bunch of chemicals that have the good effects. And the way we discovered this out, unfortunately, was not with a peer-reviewed double-blind study, but rather by getting some people and looking at them on what we call an observational study, the American Nurses Study. 1/10 of a million nurses for 20 years. and things bubble to the surface. So if you keep your weight at a good level and you do some exercise, you'll live longer. If you don't smoke cigarettes, you'll live longer. If you are poor, you die sooner. If you are black and live in a city, you die sooner. If you're overweight, you die sooner. So these is sort of all bubble to the surface, and we haven't done the peer-reviewed study.
Yeah. So one of the topics that that you had was vegan diet, which, you know, Jen knows why we'd like to talk about this, because there's been a little bit of controversy in the community that we've had around veganism recently. So
militant veganism, not veganism itself. I think we're all agreed that to some extent, cutting back on meat consumption is definitely good for us.
Yeah,
I don't
absolutely.
know that cutting it out is good for us, but cutting back is definitely good for us.
Yeah.
And certainly better for the environment. I mean, I'm not advocating we go out and slaughter cows to help the environment, but having less of them would actually be certainly a huge benefit to our environment.
Sure, we can reduce the methane emissions by feeding them by 60%, 60 to 70% by feeding them a small amount of seaweed in their diet.
Oh, wow.
Is that right?
Yeah.
Oh, wow.
Yeah, and seaweed is not actually a plant, it's an algae, but it shares roots with plants. And interestingly, they classify it by colour, red, green, or something else. Okay, veganism. Brown. That sounds reasonable. So veganism began with Donald Watson in 1925 when he was 14 years old. And he was a country kid and he saw a pig being slaughtered. I'm reading my story off on the other screen here that I wrote, all 1,476 words of it. And so he was so moved that he stopped eating meat immediately because he could hear the pig squealing, and then eventually go on dairy. And in 1944, he invented the word vegan by getting vegetarian and just throwing away most of the word and just keeping the bit, veg. And then, okay, so vegetarian, vegan. So he made up that word. It has health benefits, definitely, of plant-based diets, lower rates of obesity and chronic diseases such as type 2 diabetes, heart disease, inflammation, and cancer. But there are 4 essential nutrients that vegetarians and vegans run a risk of being low on. And one of them is B12. Now, you get B12 from meat, but the cows don't make B12. It's bacteria that have invaded them, that live in their gut, that make the B12, and then floods through the whole body of the cow, into the cow meat, and then into you. Vegans can get B12 in some algae or plants that have been contaminated or exposed to the bacteria that make this B12 vitamin. But it's not directly in plants. So you really have to get it added as in non-dairy milk, MILK or MYLK. So B12 is a problem. We can just, a little spray. Another one is calcium. And here's a weird thing. To get the same amount of calcium bioavailable in their body, vegetarians and vegans have to drink more milk than meat eaters.
But vegans won't drink milk because it comes from animals.
Well, MYLK. The point is,
the alternatives, yeah.
Yeah, they have to have a higher input of calcium to get as much in their blood.
Wow.
Because some plants contain chemicals that bind to the calcium and take it out through your back end and make it unavailable to your body. So these include oxalic acid found in spinach, rhubarb, and beans, and phytic acid found in soy and seeds and grains and nuts and some raw beans. So they need to have more calcium than the meat eaters. Thirdly, iodine is a big problem. But if they have iodized salt, they're okay. But if you once again, if you really love your brassicas, like cabbage, broccoli, sweet potato, maize, Brussels sprouts, you also get a bunch of chemicals that interfere with the absorption of iodine. So if you're a plant eater, you've got to have more iodine than the meat eaters have. And then finally we get to iron. Iron is one which, once again, it gets absorbed. So when I was working as a medical doctor, we'd come across guys who, uncommonly elderly men, whose wives had died before them. And they were iron deficient because they were living on a tea and toast diet. So they get up in the morning, have a cup of tea and a bit of toast. Then they have a bit of toast for lunch, and they have a bit of toast for dinner, and then they go to bed. And they end up iron deficient because both the tea and the wheat contain chemicals that preferentially suck whatever iron they've got in their diet away.
Oh, wow.
So if you're a vegetarian, you should not have a cup of tea within 2 hours of the meal, because a cup of tea can absorb the iron. But it is possible.
More benefits for coffee.
Yes. So, so going to the most extreme case, if a woman gets pregnant and is a vegan, if she really understands her diet well, she can have a perfectly normal pregnancy and deliver a perfectly normal baby. But she has got to have a level of knowledge about what she's eating more than the average meat eater and more than the average person. And then secondly, the baby can be brought up as a vegan as well and be perfectly healthy, but it's hard, and you have to do all sorts of tricks like cut back on fiber and give them more fat. Because they're growing so quickly, they need the fats for energy, and fat has got more energy than glucose. And in fact, if you give them non-calorie type fiber, which has many benefits, they end up not getting enough calories and falling off their growth curves. So it is possible, but you've got to really know what you're doing. You can't just get sort of meat and 3 veg, throw away the meat and say, okay, I'll live off these 3 veg now. I'm now a real vegetarian or vegan. It doesn't work like that.
No.
You've got to know your foods.
You do. And if you're somebody like me, because I have pernicious anemia.
Really?
Yeah. So getting away from having meat is really, really difficult, because I'd have to have put even more into my diet, and then it just gets ridiculous. It's too hard to do that when you have pernicious anemia.
Wow.
Yeah. And as I mentioned earlier, I have ADHD, and apparently there's a very strong correlation of iron deficiency and ADHD. Something like 70% of people, 70% of kids that have been diagnosed with ADHD have iron deficiency.
Wow. How did that happen?
Yeah. I don't know. So maybe it's a chicken and egg thing, because one of the a lot of the symptoms for ADHD are also symptoms for iron intolerant, like iron deficiency. Like,
really?
Yeah, like easily distracted.
You're giving Dr.
Being
Karl
depressed.
to research for his next book.
Yeah. Yeah.
Well, read up. I don't do any research anymore. I just read what other people have written and then plagiarize their work.
Yeah, so things like depression, like people who are low in iron tend to become quite depressed because they don't have as much oxygen running around in their brain. So and coffee, it's brilliant stuff. So there's a lot of problems with that, where iron deficiency and ADHD are strongly correlated, and we don't know, like, again, is it the chicken and the egg? Like, does somebody have ADHD because of their iron deficiency symptoms, or does ADHD cause a problem with absorption of iron? Anyway.
Yeah, it's amazing to think that even today, there's still so much we don't know about the field of nutrition and dietetics. And for some reason, this is where a lot of people think that because they eat food, therefore they know all there is to know about food. And they pick up words like B12 and iron, and then they start just making up crap.
And
so we've had people say things like, God made a mistake with giving women the potential ability to breastfeed babies, and instead you should not give babies breast milk, but give them this iron, this animal broth that I've got, this meat broth, which if you did feed it to babies would kill them of vitamin A poisoning at about 4 months of age. So people have actually done that. And, the whole paleo diet. And there's so many people who go off on all these crazy diets. For me, I think I found the truth by following somebody else, Michael Pollan, Pollan. And he's written several books. The good one is In Defense of Food. Defense is not the thing that divides one block of land from another, but as in the defense department of a country, which in fact has nothing to do with defense, but with offense. But anyway, In Defense of Food. And I can sum his book up into 7 words with 2 commas. Eat food, comma, mostly plants, comma, not too much. So food is stuff that you and your parents and your grandparents would recognize, not something that's blister sealed, vacuum packed, and you need a chainsaw to get out of this packet. And often you can eat it without cooking it, right? Eat food, mostly plants. Sure, you can have a bit of meat, but not too much. But meat is good. It has got many advantages. We need to work with meat and animal cruelty, and I'm thinking we're heading down the pathway of genetically growing it in vats, such a handy source of food.
Insects are another good one.
Insects are a good one. So eat food, mostly plants, because and vary the plants, because they've got all sorts of different chemicals in them. And there's no such thing as a superfood. Just try a bit of everything, not too much. That refers to the fact that there's a 20-minute time delay between when your tummy is full and your brain gets told about it. And this goes back to an evolutionary thing, that if you come across a dead dinosaur or endangered whale and you haven't eaten for 5 days, you just keep on eating beyond when you're full, because you might not come across a dead dinosaur or dead whale for another few weeks or so. And by the way, the world record for not eating any food at all is 54 weeks. And the world record for absolute constipation, talking about the transient anus, is 6 months.
Yes, I remember listening to Triple J when he told us about that, and he was like vomiting his feces. It was gross.
Wait, hang on, back up a bit. Hey, come back again. Say that again.
Fecal vomiting. He was so backed up it reached. I remember you talking about this on Triple J ages.
Somebody else.
Really? Oh, okay.
So this guy had absolute constipation where nothing passed out through his anus for 6 months, nor was he vomiting it up.
Oh, okay.
And somebody had to manually disimpact him. And let me just say the words long-handled teaspoon and leave it at that.
Yes, I used to work in a sterilizing department, and they had to do that procedure for someone, and it absolutely stank out the entire operating theatre. And I was in the dirty room at the time, which meant that I had to clean it up.
Oh, you poor thing.
Winner.
What about mouth breathing? Did that make it less?
What was that, sorry?
What about mouth breathing? Did that make it less smelly?
Probably. I just remember we had the this lemon scented stuff, and I was like, get it in there, get it. It's just like, going, oh my god, this is horrible. So bad.
I love you, Mary.
Yeah. So the joys of working in a sterilizing department. That's some.
Okay, here's the story. We're running out of sand.
Yes, I've heard about that.
I've heard this, yes.
Isn't that amazing?
Yeah.
And when they built in Abu Dhabi, which is surrounded by sand, the world's tallest building, they had to get the sand from Australia. Because desert sand is no good for construction.
Oh, wow.
Oh.
Because desert sand is moved around by the air. And so what you've got is high speed with light pressure. And you end up with the grains being rounded off beautifully. And therefore they won't interlock. Don't know if they're finer. They're probably finer. But the thing I got out of the article is that they were smoother. So they were less bumpy on the surface. So they wouldn't grip. Whereas what you want is marine sand, which is ground under higher pressure. The water's pushing it at lower speed. And when they built their islands there off Abu Dhabi, they used up all of the marine sand that they could find in the area. So they had to import some from Australia.
Oh, wow.
I know,
Well,
Basically, we're losing a lot of our coastal sand to construction.
yes. There's deaths on it. There's wars on it. We're heading more and more into the ships just steaming up and down off the coast, just doing something and you don't know what they are, and they're just dredging all the sand. And then that'll mean 5 years later that suddenly the sand relocates from the beach, and then you've got a bunch of rocks instead of sand. But we can get around it. So, by the way, here's a little diversion. The number of grains of sand on Earth is roughly equal to the number of stars in the universe, which is roughly an Avogadro number.
Yes, I knew about the. I realized that at first year chemistry, I looked at the number of stars, and I was like, "There's almost a mole of stars." Oh my god! It blew my mind.
Now, can you explain that to the audience, Dr. Meredith, what a mole is and an Avogadro number, while I sip on my little coffee?
Okay, so a mole is a massive number. It's huge. It's 6.022 times 10 to the 26. So that basically means after the point, you've got to put 26 numbers. So 6.022 with, hang on.
23?
23. Yes, 23 zeros on the end of it. It is huge. And every element has its weight. So a hydrogen is made up. A typical hydrogen is made up of a proton and an electron. Helium is typically two protons, usually two neutrons and two electrons, and it just goes down as the bigger the element, the more protons and neutrons and electrons there are. An element is defined by how many protons that are in the element. So you will never have a hydrogen that has two protons. That's going to be in helium, and vice versa. All carbons have 6 protons, but it can have different numbers of neutrons. And just due to a quirk of chemistry and history, we base the molecular weight on the typical carbon atom, which is 6 protons and 6 neutrons. And 1 mole, which is 6.022 times 10 to the 26 carbon atoms, weighs 12 grams. Well, roughly 12 grams, 12.01 grams. Or 12.008 grams for people who want to go that little bit more precise. And that's because the typical carbon atom has 12 neutrons and protons, so 6 protons and 6 neutrons. And that's why hydrogen, the typical hydrogen, weighs 1 gram of it is 6.022 times 10 to the 23 hydrogen atoms. So, as I said, as you get further down the periodic table, the heavier they become and the more dense they are. Like, for example, this is bismuth. If you were to get 1 mole of bismuth, it would weigh a lot more than gold, for say, because it is a heavier element. But they still have 6.022 times 10 to the 26. The closest equivalent that you would have, that most people would understand, is that a dozen is 12. So whenever someone says dozen, they mean 12. So whenever someone says mole, they mean 6.022 times 10 to the 26. So it's just an easier way to say that massive number, because imagine if you're a chemistry lecturer and you didn't have the word mole, you'd just be saying it over and over and over again, and it gets tedious. Any questions? Do you think
There will be an exam. We're expecting you to get 80%.
Yeah. So everything can be a mole. So if you can have a mole of grains of sands. You can have a mole of grains of sands being basically what's on the planet. Stars, you can have a mole of stars, which is more than what the universe has. But yeah, you can have a mole of anything, just the same as you can have a dozen eggs or a dozen buns or a dozen whatever. It's just, yeah. So a mole is a number.
There, Mara. It's more than what the visible universe has.
Visible, yes, that's true. Yeah. So, anyway.
Okay. Any questions, or will we move into spiders can count and spiders can fly?
Oh,
Ooh,
let's
I do have something to say, though. We are actually running out of phosphorus as well. Did you know that, Dr. Karl?
Tell me more. No, assume I know nothing. Tell me more.
So this is just a brief thing that my microbiology lecturer told me. We are running out of phosphorus because of the non-biodegradable dishwashing detergents and things like that are binding irreversibly phosphorus, and we are running out of phosphorus due to that. So there's
really,
so there's
but
been
we need phosphorus. All living things need phosphorus. So
yeah,
ultimately,
that's
if we
not
don't
good.
find better ways of making washing detergents, regardless of climate change, we're killing ourselves.
Yeah,
why
apparently
not do it now?
Apparently, it's going to probably hit us earlier than climate change. Phosphorus
really?
shortage.
Wow, do you have a paper on that? Can you send me a copy of it, like a review paper?
Have a look for you on that one. As I said, this was just a brief thing that my micro lecturer, I haven't looked into it, but she was like, this is a really serious thing because phosphorus is a part of our DNA. If we don't have phosphorus, we don't have.
But not just our DNA, everything's DNA. So you disrupt phosphorus, you disrupt the whole planet, every single ecosystem.
Yeah. So just, I'll look it up for you, Dr. Karl, and I'll see if I can try and find a paper.
Like, we won't run out of phosphorus. It just means that the price goes up by a factor of 10 or 100 or 1,000. And suddenly we're causing all sorts of damage trying to get to it. And we should just simply, at this stage, redesign. So that's it. We should redesign our dishwashing substances so that they do not incorporate phosphorus.
Yeah, so that they don't irreversibly bind with phosphorus.
Well, is there such a thing as irreversibly bind, or are we just talking that it's not financially viable to unbind it? Because most chemical processes have a reverse function. So
most do, but this is one of the ones that will. It's like trying to undo rust, kind of thing.
Right. So you can't do it. Well, just remember the motto of the US Air Force: with enough energy, a pig will fly. Yeah. You know, if you really want a pig to fly, you can do it. You might have to use all sorts of dynamite or spaceships or whatever. And in the same way, with enough energy, you can reverse the irreversible reaction, but you've just got to pour in that energy.
And then then you actually do more damage from pouring in the energy than what you're solving the problem. Yeah.
It reminds me of the companies, several dozen companies that were making CFCs when we discovered that they were punching a hole in the ozone layer, or rather thinning it out, to be more precise. And their first response was, it's impossible. We can't do anything. And the governments of the world, via the Montreal Protocol, stuck together and said, doesn't matter, do it. And they said, okay, and they did it.
I'm going to throw a question at you, Mero, because you explained the mole to everybody. So what actually causes the mass for those subatomic particles?
Oh, actually, that's more. Okay, so the subatomic particles. This is probably more physics than chemistry.
It is.
That's
why I threw it at you. I throw you off your field.
Okay, throw me way out of my field. Okay, it's subatomic particles. A neutron, which is a part of the atom that has no charge, has the weight of 1. A proton, which has a positive charge, has the weight of 1. And the reason why we have neutrons is because the strong nuclear force, I think it's the strong nuclear force, sticks the protons together. But of course, opposites attract. So same repels. You can't have a proton next to another proton, or else it'll just destroy the nucleus of the atom. So the binding strength of the neutron allows overwhelms that the electro force, the force that repels the protons, and the electrons has the same charge but negative to a proton, but it also has a weight of 1 over approximately 1600. Is that right? Or 1800?
The ratio of the mass is 1 for the... I'm just looking it up here, so I'm cheating. I'm sure I wrote about exactly this topic in my last book. Proton is 1, neutron is 1, electron is 0.3055.
Yeah. So they're very, but they have. Yeah, but the weight of a electron is the same of a weight of the strength of an electron is the same strength of a proton in charge, but they have different weights, of which I have no idea why.
Okay, well, so
yes.
I can
Dr.
answer that
Karl.
question for you.
Oh, Dr. Karl. Actually,
Okay.
that was a question I've been wanting to ask.
Well, we're running out of time, so I'll make this a quick answer. So atoms are made of electrons and protons and neutrons. Electrons are the end of the line. You can't go smaller. We'll talk about that another time. But protons and neutrons, you can go smaller into quarks. And there's a dozen or so quarks and antiquarks. Now, quarks and electrons have mass, and we've proved how they get mass, and it involves fancy physics and the Higgs field. And because these are what we call fundamental particles, by merely existing in the Higgs field, a Higgs boson is exchanged and the property of mass is conferred upon them. And this won a Nobel Prize, Large Hadron Collider, etc., etc. The problem is that the Higgs field gives mass to only 9% of the mass of the atom. The remaining 91%, as I wrote here, I just want to get my words exactly correct, comes from moving stuff. So there's something holding the quarks together, and that is 91% of the mass of the atom. And they're held together by things called gluons. And gluons have got this weird property. And we remember we're in crazy quantum land where, and I'm going to quote here exactly because I want to get it right, gluons spontaneously turn into quarks, even though they hold quarks together, and then back into gluons. And how can this happen if quarks are fundamental particles and can't be made of anything smaller, and yet they can be made of gluons coming together? I know that's quantum chromodynamics for you. And so you can create pairs of nothing out of something and put them back together again, so long as you do it in a short enough time. So it's kind of like the teenagers in the movies borrowing the parents' car on a Saturday night, providing they do it for a shorter time, enough time. It never happened. So we've got the situation of the inside of a proton is a seething quantum soup of lots of gluons and pairs of quarks winking in and out of existence all of the time. And because they're doing that, they're moving, and this gives them sort of like a kind of relativistic quantum mass. So 91% of the mass of an atom is moving stuff. It's stuff that's moving around. To be precise, 32% comes from the energy of the quarks bouncing around inside the proton and the neutron. 36% of the mass comes from gluons, which have no mass of their own.
It's the energy.
And how can they give mass?
Yeah, it's the energy
because they're
of
holding together, and this appears as energy and mass. And finally, 23% of the mass of the proton comes from the weird quantum effects due to quarks and gluons interacting with each other, and only 9% is the Higgs field. There will be an exam on this as well.
So basically, you can think of atoms as little tiny pockets of massive amounts of energy, because as we know, E equals mc squared, energy is mass. So you've got all these energetic reactions happening in one little area, and that energy concentrated gives us the mass of the particle
via Einstein's E equals mc squared. So you did right. So basically 91% of the mass of an atom is frozen or coagulated energy.
Yeah.
So we are beings of energy. Mass is
And
almost.
stardust.
You could almost
we
say.
are golden.
Yeah, you could almost say that the concept of mass is almost it's almost artificial. It's like we have this concept of mass, but it's really just energy that's concentrated.
And yet we were able to, using F equals ma, get to the moon and back. And so when I was in New Guinea, I actually took the students through the whole equation, and they said, we didn't go to the moon. Yeah, we went to the moon. And I managed to get a movie, which I ordered from NASA, and showed to them on a film projector, and then took them through the physics of how we get out of the Earth's gravitational field on the ground into low Earth orbit. We then take the spacecraft to pieces, reassemble it, fire it off towards the moon, slow down, go into orbit, break the spacecraft again, land on the moon, etc., come all the way back. And they're going, wow, did we do that? Yeah, we did that.
Wow. We've got one question from Bud123. Can we have a mole of dark matter?
Don't know. Really deep question. We're sort of running into problems here with dark matter. On one hand, we are very, very confident that there is some sort of mass making up 90% of the visible universe that we can't see. And because of the way that galaxies spin on their own axis, or the way that galaxies all orbit their own common center of gravity. There's a missing 90% of the mass. We'll forget about dark energy for the moment. What it's made up of, we don't know. And that is a real problem, because we've been looking at it for long enough, beginning with Franz Zwicky in the 1930s, and then Vera Rubin in the 1960s, and then really getting into it big time with so many people looking for it, and we have got nothing. We got nothing. We got a whole bunch of theories. Do we have any hints, any problems popping up when you do an experiment and somebody says, oh, that's it, odd? No, we got nothing. So to answer your question, if it is particles, you can probably have a mole of them, but we don't know if it's particles or not.
We probably have better theories on what dark energy is than we do about dark matter.
Yeah, so if you look at the whole universe, the stuff that's made of atoms is about 4 or 5%. Dark matter, which has mass, and that's kind of all we know about it, is about 25%, and dark energy is about 70%. And the trouble is that when we try to figure it in with Einstein's general relativity, we come out with energy density that is wrong. You thought the 23 zeros was big. Try 120. We are out by a factor of 10 to 120. This is in my 40th book about how wrong we are. There are big problems in physics, and when we get through them, I like to think that we pop out on the other side having some degree of space travel.
Probably part of our problem with our concepts of the energy density of the universe is that our universe is only a tiny, tiny window on the larger universe.
That's another part of the problem. You're right.
I mean, even the concept of dark flow and expansion of the universe, depending on the size of the actual size of the universe beyond our visible universe, which is possibly infinite, there is so much mass and matter beyond what we can see that the gravitational pull of that could be a large contributor to how the expansion of the universe works, and that totally changes how we can look at dark energy, because we just don't know. And especially now that we've got papers which have shown that the expansion of the universe is not consistent across the entire universe, and the flow of the dark flow is different in different areas of the universe, that would tend to show gravitational anomalies beyond our visible universe. So
are you talking about the great attractor, or are you talking about the sponge shape?
No, they've been studying dark flow as in the flow of the expansion of the universe due to dark energy across the entire universe, and different parts of the universe are actually expanding at different rates, and it's not due to distance, it's just different areas are, and that consistency of expansion isn't there. It's not there when you look at the bigger picture. So you find some areas are expanding towards things similar to when we talk about the Great Attractor, but things beyond the visible universe. So they're sort of expanding at different rates to things beyond the visible universe. So there's obviously a lot of mass beyond what we can see that interacts with our visible universe. So some of that is probably influencing what we see as the expansion of the universe.
But add time. The trouble is that influence, according to our current theories, can travel at only
the speed
of light.
Yeah.
And if it's beyond the event horizon of our universe, the observable universe,
it shouldn't have an effect. No, it shouldn't.
It shouldn't.
That's also a
right.
problem.
Good point. Yeah, it shouldn't.
That is a problem as well. So it's like, okay, so is there something beyond that? I mean, it's conceivable that there are things within the universe that can have effects that are super relativistic. Oh God, my brain wouldn't.
Super relativistic.
Yeah, I know. It almost sounds like a Disney song, doesn't it? I don't know if you're going to try and do that. But it just goes to show that our little fraction of what we know about the universe is so tiny compared to what there is to know. Well, I don't see us as a species ever knowing everything. I don't think it's possible.
Yeah. No.
Well, Freeman Dyson did say that the right shape for a human being is, forget this meat bag, a cloud of iron vapor weighing 50 kilograms, the diameter of a planet floating through space. Read his book, Disturb the Universe. And in that case, you're virtually immortal, so we can still be human, if you count being a cloud of iron vapor human, and be immortal.
Yes, which would be interesting.
All right, well, we unfortunately have come to the end of this amazing conversation. I'm so sorry, everybody. I have had so much fun. Dr. Karl. Dr. Karl, please let us know who you are, where we can find you, and all that jazz.
Easy. Go to drkarl.com, drkarl.com, and there's stuff there. There's also a Wikipedia entry, which I encourage people to add fictitious things to about me. So for a while, apparently, I'd been kidnapped by gypsies and was brought up as a lion tamer before I began studying obstetrics at the age of 15. Excellent. It said so a few days ago, so feel free to creatively modify my Wikipedia entry, just drkarl.com, and ring you with questions on the various radio shows, all there on drkarl.com.
Yeah. I will ask Dr. Karl to link me those times and dates and things like that. So
I'll be in the description.
To put in the description. Jen, who are you?
Oh, people know who I am. I'm Jen from Jen's Go check me out. The links are in the description. So,
yeah. And my name is Meredith. My channel's name is Navadia. I do a whole heap of stuff. My latest video was me talking about a eating disorder called ARFID. And yeah, check that one out. I think that one's got a really important message in that as well. So over all of that, I have to say thank you to Jen for joining up, and Dr. Karl, of massive honor and pleasure, and thank you for being our first guest on Scinomics. So thank you so much for that, and I hope everyone has a wonderful day, evening, night, whatever, and don't forget scandium, iodine, nitrogen, and cerium.
What was the next one?
Cerium. Are we able to talk?
8, 7